When we talk about waves and what waves are, the beginning of a lot of what we're going to talk about has to do with mechanical waves. Mechanical waves need a medium, and a medium is something that the wave will move through. So often this is, we think of air or water, or in our activities, we use springs. Those are the mediums at which our waves are moving through. So the two types of waves we tend to see are transverse waves, where I have a oscillation that doesn't match up with the way the wave's actually moving. So we have an oscillation, a vibration, a cycling that is, we would call it like perpendicular to the velocity. So I shake my hand left or right when I'm holding the spring, but I watch the waves move away from me on the spring that I'm shaking. Longitudinal waves are sort of the opposite of that. If we take a spring again and we like scrunch it up, we have a scrunched up section and then an expanded section as we look at our wave. And so we see the opposite of that. We have our oscillation. In this case, it's like compression and expansion. And that runs parallel to the way that the wave's actually moving. If this is a spring, I would pull it towards me and scrunch it up and then watch it expand in the same direction that the wave's moving. Those aren't as common, but it is important to note that that's the type of wave we tend to see when we talk about sound. So when we get to sound, sound is a longitudinal wave. So as far as labeling the parts of our wave, some of this we might be more familiar with from maybe math class or just general terminology. So like the peak of any wave, we're going to consider to be a crest, and sort of the valley of any wave, we're going to call a trough. Other things we might want to label on our wave, we could think about their amplitude, which is sort of the height. That one you might be familiar with from math class, but one that might have a different name would be like this 0 point. So this line through the middle would be 0, or we might call it like the equilibrium point, because it's sort of our middle. If we were thinking about the spring lab where we shook the spring, it's like where our hand starts. And so also in here, there's other things we can look at. So we have our crests and our troughs, we have our amplitude, but we can also think about the length of one particular wave. So if one wave starts here, it moves through this valley up to the peak and then back to the equilibrium point. Well, one full cycle, like that is our wavelength. One full cycle could be in a lot of different places though. We could go from that crest to this crest. That would be one full wavelength. We could go from this trough to the other trough. That would be full wavelength. Any one full cycle of any point, we call them points that are in phase with each other, represent one full wave, and the distance will be one wavelength. Now, frequency is tougher to think about with a picture because frequency involves time. So these snapshots that I've drawn sort of both represent 1 second of time that's passed. Frequency we tend to define as like the cycles per second, which give us a unit of 1/seconds, which is also the unit of inverse seconds, which sometimes we call a hertz. The period, though, is the time for a cycle, which we're going to measure in just seconds because it's time. So if I think about these two pictures, both occurring in 1 second, well, in 1 second, I'm going to have 1.5 waves in that 1 second. So like that's the cutoff of my first wave. But in this one, I have 2 waves in my 1 second. And so the bottom wave would be a higher frequency than the top one because more waves are happening in the same window of time. The inverse of that is the period. It's the time per wave. So this one would be 0.67 seconds roughly for one wave to happen, whereas the other one would be 0.5 seconds per wave to happen. Because if I have waves happening more often, then each wave must take a shorter amount of time, which leads us to t period, we could put that over here, is inversely related to the frequency mathematically, because if I think about sort of that measuring tool of just using waves.